In today's lesson, we are going to be working with percent change. Now, percent change is something that does have a formula that goes with it. However, we aren't restricted to that formula like you might want to be. As long as you understand how percents relate to amounts and how they happen to change them or increase them or decrease them, then you're going to be in really good shape. Percents can be used to describe a change. So what I'm thinking about is if you have ever listened to maybe a radio report or a news report that talks about percent increase in sales. One that I can think of is a Walmart increased their Black Friday sales by 20% this year compared to last year. Well, that means that the amount of sales that they had this year increased 20% from last year. And we are going to learn the mathematics that makes that possible. So percent change is the ratio, because percent is a ratio as well, of the amount a quantity changes compared to the original amount of that quantity. So we have percent increase and percent decrease, and those things they tend to make a lot of sense. If the amount goes up, you're going to have a percent increase, which describes how much the original amount increases, and then you're also going to have a percent decrease if the original amount decreases. And the percent is somewhat of a description of an amount. So again, if Walmart's sales increased 20%, that describes the increase to people who may be listening or watching a report. So here's an example to kind of get us started with the mathematics of it. When Jim was exercising, his heart rate increased from 70 beats per minute to 98 beats per minute. By what percent did his heart rate increase? Well, first of all, it tells you that his heart rate increased. So we're going to be talking about a percent increase, okay? So we do have this formula that we could use. I would urge you to keep it in mind. Oftentimes we forget it, but it's okay because we're going to have a solid understanding of percents. Percent change equals the amount change divided by the original amount. And I want you to recall that percent change, if it comes out, it's going to represent a percent, but because when we calculate, we don't calculate with percents, this is going to be calculated as a decimal amount that you're going to have to convert back to a percent. So the first thing that we need to think about here is how much did the heart rate change? He said he increased from 70 beats per minute to 98 beats per minute. So the amount that it changed, we're always going to work with a positive amount, whether it's an increase or a decrease. So in order to find that amount, we just find the difference. So 98 minus 70, that's going to give us a difference of 28 beats per minute. So that actually is the amount change, okay? That's the amount that would be plugged in here. So I'm just going to kind of put it right there next to it right now. Where did the heart rate begin? This is going to be the original amount, okay? It's like last year's sales at Walmart, the original amount. And it increased from 70 to 98. So where was it originally? At 70 beats per minute. So that would be here, okay? So the amount change is 28, the original amount is 70, so that is 28 divided by 70. That's going to give us our percent change. But you already know that 28/70ths is less than 1, so it's going to give us a decimal amount less than 1. But that doesn't mean that our percent is less than 1%. We're going to have to change it to a percent, okay? So 28 divided by 70, let's go ahead and do that very quickly here. I'll add my decimals. And 70 goes into 280. Well, 4 times evenly, that's going to be 280 exactly. So I didn't need that extra decimal place, but I can put that 0 there. If the percent change comes out to be 4/10, we know that 4/10 as a fraction is 4 over 10. That's 40 over 100 as a percent. We multiply decimals by 100. So by multiplying by 100, that moves my decimal place twice, giving me 40%. So to answer the question, by what percent did his heart rate increase? His heart rate increased 40%. And that's because 40% of 70 is 28, which is how much his heart rate increased. Okay? Here's another example. William has 765 baseball cards in his collection. He then sells 153 cards. By what percent did his collection decrease? So we just have to interpret the problem here. He had originally 765 cards. And then the amount that it changed was 153. It tells you he gave away 153 of them, right? So you could think, but so what percent of 765 is 153? Because that's going to be the percent of 765 that his collection changed, right? So we could, based on what we know about percent of a number, say what percent of 765 is 153. But what's interesting is when you are to solve for the percent, you would divide on both sides by 765, right? So if I divide by 765 on both sides to isolate P, I end up with 153 divided by 765. So I end up with the percent change equals the amount change divided by the original amount. It's nice that it works out this way for us, and it actually always will, as long as we know what goes where and why. So I say here, finding the percent change depends on your understanding of the scenario. You can set it up this way. There is nothing wrong with that because it's going to turn into this anyway, which is how you're supposed to calculate it. The formula is kind of a shortcut. That's okay too, as long as you understand why. So 153 divided by 765. This is going to be kind of intense, but we can do it. I'm going to guess twice because I'm thinking 700 would go into 1400 twice, and I know they're both a little bit more. So 765 times 2, that's 10. That's 12 plus 1 is 13. Now we're looking good. 14, 15. Indeed, it's exactly 0.2 2/10. 2/10 is going to be, when I multiply it by 100, 20%. So that's a 20% decrease in his collection because 153 cards is 20% of what he had initially. Okay? Let's try this one now. A population of geese rose from 234 to 460 over the period of 2 years. What is the percent increase to the nearest tenth of a percent? So the geese had a population from 234 to 460. So first I want to know what the difference is. That will be my amount change, right? So if I do that, that's going to be 460 minus 234. That's 5 there, 5 tens. 10 minus 4 is 6. That's 2. So it changed 226. I'm just going to label that on my paper because that helps me keep track of my thoughts. Now it changed 226 and it started at 234. What percent of 234 do you think 226 is? 226 is almost 234. So it's going to be kind of close to 100%. I'm thinking in the 90% range. If it grew 226 geese and we started with 234, it almost doubled. And if something doubles, that's a 100% increase. Think about that, okay? So the amount change, what percent of 234 is 226? If we do the amount change divided by the original amount, then, let me set it up this way here instead. Divided by the original amount. This is to the nearest tenth of a percent, so I'm probably going to have to do this 3 times. Like I said, I'm estimating it's going to be in the 90% range, so I'm going to multiply by 9 to start. That's 36. 9 times 3, 27 plus 3 is 30. That's 18, 19, 20, 21. Lo and behold, it fits nicely. So above there, I'm going to put a 9. That's 2106. 10, that's 4, 5, and 154. Bring down my 0. So I think it's going to go in, this is about 200 into about 1,500. I'm going to say 7 times. Let's try. Let's try 6 instead. Times 6, so 24, 18, 19, 20, 12, 13, 14, 04. Yep, and another 234 will not fit, so we're good here. So that's 6, 14, 04. That's 310, 6, 3, 136. One more time. Give me an idea of what I'm working with. I think that's going to be 5 times based on what I know here. So 234, I'll do it up here, times 5, 20, 15, 16, 17, 10, 11. Yep, it works. So that's just a 5. So when I change this decimal value to its percent equivalent, I multiply by 100, which moves my decimal twice to the right. When I do that, 96.5% is going to be our answer. Okay? 96.5%. And it's a 96.5% increase. Remember I said it was going to be close to 100%? Totally makes sense, right? Okay. So now I've got some situations and scenarios that work with money. And this is probably where you're going to see this happen the most, is with amounts of money. But in this case, it's not the percent that we're looking for. We're actually given the percent increase or the percent decrease. So let's kind of see what happens here. If I have an original price of $500 and it increases by 20%, what is the new price? Well, there are a couple ways that you can think about this. 20% of 500 is what? And then if it increases 20%, you will add that amount to it. Because if it's going to increase by 20%, obviously it's going to get larger. So you could say 20%, which we know is 2/10 or 20 hundredths of 500, that's going to be 100. And if this is the amount change, right, that's going to give us the amount change. If it increases by $100, then we're going to say $500 plus $100 is $600. Let me show you using the percent change formula equation, so to speak. So we'd say percent change, which is 20%, equals the amount change, which we don't know, divided by the original amount, which is 500. Yes? In order to solve for that variable, you know the opposite of division is multiplication. We would multiply both sides by 500. And by doing so, we get that x equals 500 times 2/10. Well, we know that that is 100. If x equals 100, and that represents the amount change, and we know that it increased, again, if it changed by $100 and it's an increase, we would add it to the original amount. 100 plus 500 is $600. So let's make that known here. Okay? Always ensure that your answer makes sense. If you were to subtract, did that show an increase? An increase? No. It would show a decrease. So you need to be sure of that. Okay? So there's that one. This one's looking for an original price. Now this is going to get a little bit tricky, but try to follow. Watch, then go back and copy, maybe watch it again. Just listen to what I'm talking about, okay? So I don't know the original amount, but I know that the original price decreased by 5%, and now the new price is $4.20. So 5% of something, and then subtracting that amount gives me that amount, okay? So 5%, which would be 0.05, times the original amount, and the original price subtracting this, so if okay. The original amount minus 5% of the original amount. So if the original amount is X, then I'm going to take away 5% of it to find out that the new price is $4.20, okay? So obviously the original price is going to be greater than the new price if it decreased by 5%. So here you know that I have 1x minus 5/100 x. I'm allowed to combine like terms. That's going to give me 0.95x. And that's going to say, well, 95% of x is 420 because 100% of x is the original price, right? 100% of that is it. And so 95% of that original price is now the new price because it decreased by 5%. Hopefully that helps it to make sense. And now to solve for x, I would do my division here. And so that's leaving me with 1x. Now 95/100 into 420/100. If I do that division, I have already in my head multiplied both of these by 100. Moving that decimal, I'm allowed to do that because of proportions. I know that I have equivalent division going on here. 95 goes into 420. I'm thinking 4 times even. Let's make sure. Times 4, that's 20. That is 36, 37, 38. How wrong was I? Interesting. 20? Yeah. Okay, 380. Yeah, I knew that. Forgive me. So that's 4 times. And so then that's minus 380. Okay, yeah, we're on the right track. So that's 40. Add a decimal and a 0. We're going to have to do that twice. Bring that down. This is also going to go in 4 times. That's 380 again. 200 this time. 95 is going to go in twice. 95 times 2 is going to be 190. That's supposed to be 200. Forgive me. And then that's 10. And then again, it would go in once. So the original price, guys, it's $4.42. Probably going to have to do this one for you again, but that's okay. The original price is $4.42 because I solved for x in an equation I set up myself. Notice that I didn't use the percent change formula. I actually had to think about what I understood about percents. Okay? And the original price is greater than the new price because the percent decreased. Lastly, Mr. Simmons owns a hardware store and typically marks up merchandise by 28% to make a profit. So how much would he charge for a hammer that cost him $13.50? So the percent change is 28%. So I'm going to say, well, that's 28/100 is the amount change, we don't know what that is, divided by the original amount. And we do know that that's $13.50. So to solve for the amount change, remember that's what that is there. I multiply by 1350, multiply by 1350 here. That's leaving me with 1x, multiplicative identity. Again, 1350 times 28/100. That's 0, 40, 24, 28, 10, 0, 0, 10, 6, 7, 2, 0, 0, 8, 7, 3. 4 decimal places, $3.78. So that is the amount change. If it changed that much and he marks it up 28%, then we add that to the original amount, which was $13.50. So I can go ahead and do that really quickly. That's 8, 12, 7, and 1. So he's going to charge $17.28 for that hammer that he did in fact mark up.